All right, let's go ahead and solve this one. So in this question, we're solving for Q, and I know that the specific heat of ice is actually different than the specific heat of water. So the specific heat of ice is 2.1 joules per gram degree Celsius. I know that my mass is 2.4 kilograms. And again, if I wanted to turn this into just straight grams so that it aligns with this, I can easily do that by moving the decimal point this way 3. So it would be 2,400 grams. And my delta T is going to be what? So here I know that it starts out at 0 degrees Celsius. Then the air begins to warm. Let's go ahead and draw a quick graph of what this would look like up here. So we're going to start out, let's say that here's 0 degrees so that we can see our line. As our ice is melting, just melting, does our temperature change? The answer is it doesn't, right? Because all of the energy from the air is going directly into, let's say here's our system. So we do have Q coming in from the atmosphere, into the ice, but it's going into the phase energy because the ice is melting. And so our temperature versus time graph is just going to look like a straight line. And so here we're going to start out at about 0.0 and end at about 0.0. So our delta T is actually going to equal 0 degrees Celsius. So if I plugged in 0 degrees Celsius into my equation here, obviously that would make my entire equation 0, and my Q would equal 0. So what this tells me, and what this should tell you guys, is that we need a different type of equation for this. So when water is changing temperature, we can use this equation and use specific heat, but there's something different that we need when water or a substance is changing phase. And that's what we call, heat of fusion. Okay, so that's what we call the heat of fusion. It's very similar to the specific heat, but it's how much energy is needed to change a substance, 1 gram of a substance, from solid to liquid or from liquid to solid. So there is our definition of heat of fusion. The amount of energy needed to change 1 gram of substance from solid to liquid or from liquid to solid. And so again, this could be Q also. Remember, Q is just the flow of thermal energy. So let me grab the heat of fusion for water, and then we can do this problem. So our heat of fusion for water is 334 joules per gram. So let's go back to our previous problem. And we're going to realize we don't want this equation. We want the equation that says Q is equal to, let's write it up here, the heat of fusion times the mass. So you can see that temperature is not involved here. So let's go ahead and plug everything back in. So we have the heat of fusion is equal to 334 joules per gram. And we know our mass, so now we just plug it in and solve for Q. Grams cancels out. And I get a large number. Q is equal to 801,600 joules. Now it would be a lot easier to write this in kilojoules. So what if I wanted to express this in kilojoules? I would move the decimal point 3 places this way and add a k. I'm going to have to round up, right? So I'm going to have 102 kj. That's my final answer.